All right. So first thing today, we're gonna just talk about basic operations of the GPS shield, and then we're actually going to do some limited parsing with it. So first thing that you want to go, we've touched on this before, but basically the first part of this activity is just, you know, stacking and unstacking the shield. And we've covered this before, that basically the important thing is you don't want to do it with your hand. You want to use some of these pliers if you have access to them. But basically, you're trying to be careful and pull it straight out so that you're not bending pins while you do that. So the idea is, if you have access to these ring pliers, is what they're called. They're actually used for spreading, like I believe, cable rings and collars. So the idea is you squeeze these and it opens up the ring. But it just so happens they work pretty well for unstacking the shields. And you want to try and get in. You don't want to be putting the jaws of the pliers against the plastic. So you'll get them in here, or you may get them in on the ends here. It's just something you have to practice, and then you loosen it up. And the idea is to loosen the sides. Loosen up each side slowly, so that you're not just bending these pins by taking it out in sort of a cocked or uneven fashion. So after that, the next thing that is sort of important to do before we actually use the GPS is download the libraries. So in here, there is instructions for downloading the library manually, but you can also just use the library manager. So one thing you do want to note, though, this is the repository of the actual library. So this is what's maintained by the Adafruit people. And this is where you can make sure you have the most up-to-date version. So if you go here and you'll look, and they actually are on, where's the version number on here? It's actually version 1.5.2. Yep, sorry. Library properties. And so one thing that you want to do if you're using the library manager, so when you go in here, you go to Tools, you go to Manage Libraries, and if you type in Adafruit and then GPS, so you can see that I already have it installed. So again, if you don't have it installed, you would click Install here, and you would see the version is 1.5.2. And like I said, you want to make sure usually that you have the most current version. Sometimes the Arduino library manager can lag a little bit behind. So you could potentially run into issues with an older version through the library manager, in which case you could follow the wrong activity. Follow the instructions here to manually install the libraries. But as a general rule, it's easiest to let the library manager handle it. So basically, the first thing that we're going to do is use the direct connect on the GPS shield to just output the output to the serial monitor, that is. So one thing I want to draw your attention to is if you look at your screens, you should see the GPS. So you all can see the, this is a zoom in next to the GPS antenna, and here's the 3 LEDs on the GPS shield. And most importantly, you'll see the fix antenna. So right now, I currently have a fix on the GPS. So if I was to pull up the serial monitor, you can see that I'm getting strings spit out here, and it's there's actual data on there. But most likely, well, definitely when you start it up, and depending on where you are, you may not get a fix right away, or it may take a while. And so what you'll see in that case, I'm just going to hit the reset button here to restart the Arduino. And what you'll see is that the fixed light is going to start blinking rapidly. Whereas before it was blinking once every 15 seconds, right? And this is going, that indicates that I had a fixed with the slow blinks, and the blink like this is when you do not have a fix. So you'll see there are still strings being output. I am getting NEMA sentences, but if you look closely, you know, it's a bunch of zeros, a bunch of blanks, and or default values. The time is actually correct because, as we discussed, there's a real-time clock with a battery backup, so that was maintained. So, and I actually have to move my GPS shield just because here on the camera, I don't have a, the camera is in a spot in the room where I'm not going to get a fix. And it can take a few seconds to get a fix. So what you want to do is first you want to basically have a blank sketch because we don't want anything interfering. So I'm just going to have a completely empty sketch here. You can see there's nothing in setup, nothing in loop, and I'm going to upload that to the Arduino. And this is just to make sure the Arduino isn't trying to do anything, because I'm effectively going to directly connect to the GPS. Next, you want to if you haven't already, you can go ahead and unpower your GPS shield and then install it. And then I want the switch here, the soft serial and direct switch, to be in the direct position, which is towards the side over here. And then once I do that, I can then open up the serial port or the serial monitor at 9600 baud, which is important, which is what the GPS shield transmits at. And what you will see is basically it will just be spitting out the default values. So again, this is what you'll see. Now, I still haven't managed to get a fix, but it's outputting the all of the default strings, basically with a bunch of dummy values in there. Let me try something to see if I can make this a little bigger on your guys' screens. Yeah. So you can see I want this on 9600 baud, and if I turn off the auto scroll, it's a little easier to see. So you can see all the different sentences that we talked about in the lecture. I have here a RMC sentence, I have a VTG sentence, I have a GGA sentence, right? And if you were to pull up the resource that has the Arduino, or sorry, not the Arduino, the NEMA sentences, I could look to each one of these sentences and I would see that it's formatted like that. So once you have that all connected and you're getting the sentences, even if you don't have a fix, you can still do the next part. But ideally, you would have it with a fix, but obviously depending on where you're doing this and other conditions, that may not be possible. And also right now we are not using the software serial, so we don't need to worry about the TX and RX connections. So on the example I just showed you, yes, they were connected, but we'll be using that later. So we're actually going through the serial 0 port of the Arduino. So, and as you saw, there's no code uploaded in the Arduino, so it's effectively not really doing anything. It's just listening on the line. And what we're actually seeing is we're interfacing directly between the computer and the GPS shield itself. So one thing I can do is, we haven't ever used this before, but you have this text box up here and a little send. So what that'll do is it'll transmit whatever the text string is in this box over the serial port to whatever's on the other end. And in this case, that is the GPS shield itself. So in the activity, there's this table that has several of the commands that you can send. And the way that you actually command the GPS is just with plain text strings. So you can see that, for example, I can send this command right here. And what that should do is basically turn off everything except the RMC sentence. So instead of all of these different sentences, it's going to just start sending send only the RMC. One thing you have to watch out for is this drop box here. This is what characters are appended after this text string. And if you look at the instructions here, you want it on both new line and carriage return. So if we go back to the serial port, I've copied one of the commands in there. And now if I hit send, and I'll just clear the output, and it looks like that didn't work. Because if it did work, we shouldn't, oh, there we go. So you see, before I was getting all these different sentences, VTG, GGA, GSA, blah, 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 blah. But after this point, I'm only getting RMC sentences because I sent the command here, which tells it only to send the RMC. So for now, everyone should just try that. And I'll pause it right here. All right, so the next thing that we want to do is shift from the hardware serial connection to the software serial connection. And this is mainly because the hardware serial comes out to that same serial port that you use for programming and that you use for the serial monitor. And like I said previously, we have 3 other serial ports that that we can use instead on the Mega. So what we want to do now is first you want to power down your computer, or not your computer because that would log you off, but your Arduino, and then you want to install your jumper connection if you haven't already. And one important thing is you need to connect from the transmit pin on the Arduino to the receive pin on the Shield, and from the receive pin on the Arduino to the transmit pin on the Shield. So what that means is you want a connection. I think it's a little bit easier to, write it out. You want the GPS transmitting from itself to the Arduino, and then from the Arduino transmitting and receiving on the Shield. And you can see here on my Shield, I've just used 2 jumper wires that I soldered in. And I have this running as we discussed. And then once you get it there, you want to shift this switch to the software position. And all that does is change where the signals for the GPS unit are actually transmitted. That doesn't actually change any sort of settings with the GPS. It just physically moves them from, these pins here to these pins right here. And you can see I have these just running, and I've connected it to the TX1 and RX1 pins of the Arduino, because we're going to use serial 1 that's the serial port that we're going to use on the actual Arduino. So if I go back to the activity, and once you've made this connection, basically I want to open up a new, and let me zoom in here. I'm going to open up a new sketch, because now that we have this transmitting on those pins, we're going to have to actually write some software to read that output out, and then write it to the serial port so that we can look at it on the serial monitor. So the first thing that you want to do is we need to include the Adafruit GPS library, because that's how it's managed. And then we want to create basically the object that we're going to be talking to. So we're going to call this line here. So we're just declaring a variable, but it's a more complicated variable type. So we're going to declare GPS serial, and it's going to be serial 1. So what that's actually doing is basically defining GPS serial as the serial 1 port. So serial 1 is an object itself, which is the serial port corresponding to the TX and RX1 pins. Then we want to create this Adafruit GPS variable that we're calling GPS here. And what we're doing here is we're just pointing it at serial 1. So we're saying, hey, we have an Adafruit GPS at serial 1. And this is just similar to when you declare an integer or a float, but this is a more complex object, so we can do a lot more stuff with it, all of which is defined by what's in this Adafruit GPS library. So then we want to create a way to read this out. So like we have talked about previously, you could basically just go and try and read that thing every time you go through the loop. But if you do that, you could potentially get busy, and the buffer that all of that text gets written to could fill up. You could start missing characters. So what we want to do is use something called an interrupt. So we need to declare this Boolean variable called using interrupt. And this is just a flag that tells us if we're actively using that the interrupt that we're going to define. And then we want to declare a function that we're going to write that sets that turns that interrupt on. So next, we want to we're going to declare we're going to open up the serial port like before and do a similar sort of thing for the GPS. So if you look, where did it actually? Is that line not in here? I'll get that correct. So here, let me just pull up the actual sample code. So if we look at my setup here, if your GPS is not powering on at all, that means there's probably some issue with the header pins that you soldered in, most likely. So, like I was talking about, we want to do a serial.begin. So this is going to set up our communication with the computer. We're using a different baud rate this time. We could have kept it at 9600 like we had previously. And then we're going to call this GPS.begin. So before, like I said, we pointed this GPS object at the serial 1. So that means we can basically call the same serial functions on it because it's using that serial port. So that is what we're doing right here. So we're just declaring those initial variables. So next thing that you see in the, so one of the things that's nice about this GPS library is it has constants declared for all of these commands, so you don't have to type out what the whole string is. If you were to open up the library, each one of these commands would in fact just be a constant that's set equal to the string, like on this table up here. So you can either from the sample code or here, you can, for example, just have all of this code in there. And it's useful. So you'll see down here is basically to have all of the potential commands that you want in there, and then just comment out the ones you're not going to use. Because that way you can just have this big block of text and you don't have to go look up, oh, I want to use this command. I already have it here in my code. I'll just uncomment it. So in particular, we're going to ask for this. This is just asking for the version number. This is telling it I don't care about the antenna. And then this command is saying I want NEMA sentences every 1 second, so at 1 hertz. And then these are similar to before, where you can ask for specific sentences. And we want all of this to be in the setup. So finally, the last thing we got to do is we have to set up that interrupt that I was talking about. So this is sort of complicated, and it gets very low level in the Arduino, but this is what we recommend how you read these out. And to a certain extent, you can just trust that it works. But what you want to do is you want this block of code right here. So signal, blah, 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 and then char-c equals gps.read. So what this is this is a function that runs every time that the processor itself receives a signal on this particular, it's called a vector, but it's actually hardware built into the processor. And then the other thing that you need is the code that will actually generate the interrupt, which is in this block right here. So first of all, this is a function that you will pass either true or false to. And what it'll do is allow us to turn on this variable or that interrupt. So when you pass a true to it, it executes this part and it turns on the interrupt. And if you pass a false to it, it turns off the interrupt. How this actually works is it uses what are called registers that are built into the hardware of the actual processor. So in particular, there is a timer that is timer 0, and that's what's actually used in the millis function. And all that is a timer that counts from 0 to 255, and then every time it reaches 255 and it rolls over to 0, it increments the internal variable that gets read by that millis function. So you in fact can have another register that gets compared automatically to the value in that timer value. And that's what this OCR0A is. That is output comparison register for timer 0, register A. So each one of these timers has an A and B comparison one you can use. And what we're doing is we're setting a particular value in here. So this is just happens to be the hex value for 175. So the processor will automatically, without any software, compare the value of this register to the value in this timer. And when they match, it will generate a potential signal. I say potential because there's another register that has basically a bunch of flags in it, and that's what this register is. It's the timer interrupt mask register. So if you have a 1 in a particular spot, it will allow this to happen, and if there's a 0, it will not happen. So that's what this second part of code is. So we're just saying, hey, when you count from 0 to 255, when you hit 175, generate an interrupt. And then this second part is what either enables or disables that interrupt. And what gets called when that interrupt happens is whatever you put in this function. And in this case, we're just reading the GPS. I'm sorry that that's a little bit complicated, but it is fairly low level, but it is a much more reliable way of reading. So then the next thing that you want to do is in your loop function, it will be very simple. You will just have a single if statement And what you're going to call is if dot new NEMA received. So basically, once you finish reading out a full NEMA sentence, you will set this value to true. And then when that happens, you will just print out this GPS dot last NEMA received. And what that should do is every time you come through this loop, if there's a new NEMA sentence available, it'll print it out, and then it will continue on. So what you should see once you get this all written together, so here's all the stuff about the setup, the library. Here's the setup of the serial object and the GPS.begin, those initial commands. Here's all of the stuff with the interrupt. But then when you look down to my loop, it's just that very simple statement. So now if I upload this and make sure that it actually uploads correctly, and you can see I got this error, and that is because what it says here is there's a communication error, and that's because I unplugged the Arduino at one point while the IDE was open. So usually, if I just unplug it and plug it back in and I try and upload again, yep, so that worked fine. So now if I open my serial monitor, so one thing that's important is you probably need to change this serial monitor to 1152 because it was probably on 9600. And you'll see that I'm just getting this RMC sentence, which is what I specified in the code. But the key thing is this is actually getting transmitted through the software serial connection and then back to the computer through the serial 0 connection. So that is where we're going to stop right now, and hopefully everyone can get to this point.